2004 Scientific Revolution voiceover script. The Scientific Revolution. The rediscovery of works from ancient Greece and Rome and observations of the natural world changes many European views of the world. New ideas in science based on observation, experimentation, and mathematics challenged classical views of the cosmos, nature, and the human body, although existing traditions of knowledge and the universe continued. The medieval view of the physical world, and primarily through the lens of religion and theology. What was known then as scientific was essentially a branch of theology, and challenges to the established thought and considered heresy. Political theory based on the divine rights of kings, the idea that the monarch was appointed by God to govern. Society as a whole was governed by the church, and views, traditions, and practices with superstition playing a significant role in people's everyday lives. A superstition is a widely held but baseless belief that something supernatural caused an action or event, producing a specific result. The medieval university provided the framework for education with Thomas Aquinas and the melding of ancient philosophy and early church teaching, known as socialism. The theology of the early church fathers and a philosophy based on Aristotelian logic joined together with a strong emphasis on tradition and dogma. Scientific thought was based on systematic medieval ideas. During the medieval period, science was considered a branch of theology, and any challenges to the established thought was heresy. Scientific thought in the early 16th century continued to be based on ancient ideas developed from Aristotle, Ptolemy, and Galen. Scientific thought of 1500 was based on Aristotle's theory of the universe that dated to 4 BC. 10 spheres moved motionless around the Earth. The Earth was the center of the universe, and beyond the spheres was heaven. Aristotle's theory is well suited for Christianity. Views of the universe were largely influenced by the ancient ideas of Aristotle, a polymath that studied physics, chemistry, biology, zoology, and botany. He wrote that psychology, politics, ethics, logic, metaphysics, history, literature, and rhetoric. The Greek astronomer in the 2nd century BCE, Ptolemy, espoused the geocentric view that held that the Earth was at the center of a static, motionless universe. Thoughts on human health were derived from Galen, a Greek physician in the 2nd century BCE. By 1300, philosophy had become an accepted discipline, in addition to law, medicine, and theology. Gradually, medieval philosophers developed a degree of independence from theologians and a sense of free inquiry, leading universities to establish new mathematicians, astronomy, and physics, natural philosophy. Professorships within the philosophy department, prominent scientific figures either studied or taught at university. Moving on to the early 16th century, the Renaissance stimulated science by rediscovering ancient mathematics. Renaissance patronage was often scientific as well as artistic and humanistic. During the Age of Exploration, navigational problems and sea voyages and the Age of Overseas Expansion created a need for scientific advances. New instruments developed included the telescope, barometer, thermometer, pendulum clock, microscope, and air pump. Gresham College in England had scientific working closely with the top officials in the Royal Navy and leading merchants and shipbuilders. It became the main center of scientific activity during the first half of the 17th century. In astronomy, Nicholas Copernicus, 1473 to 1547, a Polish priest and Renaissance-era polymath, a person of wide-ranging knowledge, formulated the heliocentric view of the universe. Through observation, he argued the Earth revolved around the Sun, and the Sun was at the center of the universe. His books on the revolution of the heavenly spheres was not published until his death due to fear of repercussions from the Catholic Church. He dedicated the book to Pope Paul III, as he did not intend his theories to challenge church doctrine. He observed that the stars did not move, although the apparent movement of the stars was the result of the Earth's rotation. The universe now seemed enormous, perhaps infinite. Copernicus' theory that the Earth was just another planet begs the question, where's heaven? Copernicus directly challenged Ptolemy's 2nd century AD view of the geocentric universe. Heliocentrism also challenged the Bible's book of Genesis and put forth a geocentric view. Shown is a model of the universe which put the sun in the center, devised mathematically by Nicholas Copernicus. The model placed geocentric, which placed the Earth at the center. Copernicus not only challenged traditional Catholic dogma, but also found opposition for reformers Martin Luther and John Calvin. They condemned Copernicus' theory by pointing to biblical passages supporting the medieval geocentrism view. As a result, by 1616, the Catholic Church had proclaimed the Copernican idea as false. It persecuted those who advanced his views, as was the case with Galileo. The modern cosmology that began with Copernicus was expanded upon by Tycho Brahe, Johannes Kepler, and Galileo. Tycho Brahe, 1456 to 1601, became Europe's leading astronomer in the late 16th century. He built the best observatory in Europe and for decades collected massive data on his observations of the cosmos. His data later proved Copernicus' theory that became a cornerstone of astronomy for centuries. Ironically, Brahe did not accept the theory. He believed that while the planets all revolved around the sun revolved around the Earth. The first great Protestant scientist, Johannes Kepler, worked as an assistant to Brahe. He was able to mathematically prove the Copernican theory. He developed 3 laws of planetary motion. 1. The orbits of planets are elliptical, not circular. 2. Planets do not move at uniform speed while in their orbits. And 3. The time it takes for a planet to orbit the sun is directly based on the distance from the sun. The closer a planet is to the sun, example Mercury and Venus, the faster its orbit will be. Kepler's contributions were huge. He had mathematically proved the relations of a sun-centered solar system, aka heliocentric model. Astronomy in the 17th century had Galileo Galilei lead the revolution. He developed the laws of motion by using controlled experiments of acceleration. He proved that gravity was the universal force that produced acceleration uniformly, that all falling objects descend with equal velocity regardless of their weight. Galileo also developed the law of inertia, in which an object in motion remains in motion until some external force stops it. Galileo was the first to use the telescope as a scientific instrument. He built one himself. Through direct observation, he demonstrated that the moon and other planets were not perfectly round orbs like a crystal sphere, the prevailing medieval view. Furthermore, he discovered the 4 moons of Jupiter, thus refuting the notion that Jupiter was embedded in an impenetrable crystal sphere. He validated Copernicus' heliocentric view with the aid of a telescope, which he perfected. Galileo's findings became highly controversial in Catholic countries. However, the views were largely supported in Protestant Northern Europe, with reformers have questioned Catholic doctrines. In 1616, the Catholic Church declared the Copernican theory to be heretical. And in 1632, Galileo published Dialogue concerning the 2 chief world systems, writing about the Copernican system as a mathematical proposition. By 1633, the Inquisition of Pope Urban VII forced Galileo to retract his support of the Copernican theory. He remained under house arrest for the rest of his life. He was eventually absolved from the charges of heresy of Pope John Paul II in 1992. Astronomy in the 17th century. Galileo's most significant contribution to science was the experimental method. Rather than speculate about what might or should happen, he conducted controlled experiments to discover what actually happened. Isaac Newton incorporated the astronomy of Copernicus and Kepler with the physics of Galileo into an overarching theory explaining the order and design of the universe. His principle of universal gravitation was detailed in his book, Mathematical Principles of Natural Philosophy, published in 1687 and was popularly known as Principia, and is considered the most remarkable book on science ever written. Newton developed a set of mathematical principles to explain motion, the natural laws of motion, gravitation, the evident in the movement of heavenly bodies and earthly objects. The law included that everyone in the universe attracts every other body in the universe in a precise mathematical relationship. And since these laws are unchangeable and unpredictable, God's active participation in the natural world is not needed to explain the forces of nature. His discovery directly challenged medieval beliefs and became the foundation of the enlightened view of God, theism. He invented calculus to complete his theory. Calculus deals with rates of change, such as calculating a car speed change when reaching a red light. Key concept 1.1.4.c. Francis Bacon and René Descartes defined inductive and conductive reasoning and promoted experimentation with the use of mathematics, which would ultimately shape the scientific method. Francis Bacon, was the father of empiricism, was an English philosopher and and statesman who served as Attorney General and as Lord Chancellor of Italy. His works are credited with developing the science method and remained influential through the scientific revolution. He formalized the empirical method that Bray and Galileo had already used. Through the inductive method for scientific experimentation, he began with inductive observation, then formed a hypothesis, conducted data, and then organized the data. Bacon's inductive method coped with Descartes' deductive reasoning, formed the backbone of the modern scientific method. Empiricism is a theory of inductive reasoning that calls for acquiring evidence through observing and experimentation, rather than deductive reasoning and speculation. René Descartes wrote the Discours on Method, advocating deductive reasoning. He went as far as employing deductive reasoning to prove his existence. Cogito ergo sum. I think, therefore I am. His proof depended on logic alone. He believed science must first start with clear and indisputable facts. Then he subdivided each problem into as many parts as necessary, using a step-by-step logical sequence. Finally, he demonstrated the relationship between algebra and geometry, developed an analytical geometry. Cartesian dualism divided all existence into the spiritual and the material, and the spiritual could only be examined through deductive reasoning. The material is subject to the experimental method. The Dictionary of Psychology defines it as the position taken by René Descartes and the world comprised two distinct and incompatible classes of substance: res extensa, or extended substance, which extends through space, and res cogitans, or thinking substance, which has no extension in space. Developed analytical geometry, aka Cartesian geometry, which is the study of geometry using a coordinate system. A chart defining inductive versus deductive reasoning. Key concept 1.1.IV analytical and medical discoveries by physicians including William Harvey presented the body as an integrated system, challenging the traditional humoral theory of the body and of disease spouted by Galen. Within the study of anatomy, psychology, and biology, scientists began challenging traditional Greco-Roman medical theories of health and disease, such as the 2nd century Roman physician Galen. Galen believed the proper balance of the four humors: blood, phlegm, black bile, and yellow bile, which was the basis of human health. Bloodletting was commonly used to place the humor back into proper balance. The process required the surgical removal of some of the patient's blood for therapeutic purposes. It was either done by a physician or with leeches. Paracelsus was a Swiss physician alchemist who pioneered the experimental method in medicine. By experimenting the various chemicals and drugs to deal with medical issues that he saw as chemical imbalances rather than humorical imbalances, were the culprit of most ailments. Flemish physician Vesalius wrote The Structure of the Human Body and renewed and modernized the study of human anatomy. His publication included about 200 detailed drawings that usher in a revolution in understanding the human body. He dissected cadavers to achieve stunning details in his drawing. He was the first to assemble human skeletons. Sketches from Vesalius' book, The Structure of the Human Body. English royal physician William Harvey published on the movement of the heart and blood, which explained how blood was pumped by the heart and circulated throughout the body via veins and arteries. Known as the father of microscopy, and Anton van Leeuwenhoek developed powerful microscopes. He was the first to see and write about bacteria, yeast plants, living organisms in a drop of water, the circulation of blood corpuscles and capillaries. Governments, monarchs encourage scientific inquiry to further the state prestige and remain at the cutting edge of technology by establishing royal scientific societies. Scientific societies create a platform by which scientists could communicate with each other internationally. This helped forge an international scientific community. The Royal Society in England was the most successful and prestigious. Founded in 1616, other royal societies were created in Naples, France by Louis, in Prussia by Frederick, and Russia by Peter the Great. The impact of the scientific revolution on society led directly to the Enlightenment of the 18th century. It also impacted improvements in exploration. Example, John Harrison's chronometer gave mariners the ability to determine longitude by the late 18th century. The spirit of experimentation helped accelerate the agriculture revolution near the turn of the 18th century. Improvements in medical knowledge helped improve the quality of life later. The scientific revolution reduced the support for witch hunts by disintegrating superstition and witchcraft as facility. There were few attempts in the 17th and 18th century to secularize science, since most scientists believed that they were studying and analyzing God's creation. Universal agreement existed among scientists and philosophers regarding the supernatural origin of the universe. The debate centered on the extent to which God continued to be involved in his creation. Science and religion were not in direct conflict until the 19th and 20th centuries. After the Catholic Counter-Reformation, the Church became more hostile to science, but science declined in Italy, but not France. Protestant countries became the leaders of the scientific revolution, especially England. Key concept 1.1.4.d alchemy and astrology continued to appeal to elites and some supernatural philosophers, partly because they shared with the new science the notion of a predictable and noble universe. But at the same time, many people continued to believe that spiritual forces govern the cosmos. Alchemy and astrology continued to appeal to elites and some natural philosophers, partly because they shared with the new science the notion of a predictable and noble universe. Alchemy was the medieval forerunner of modern chemistry as it dealt with the supposed transformation of matter, as in converting base metals into gold or finding a universal elixir that would restore one's youth. No clear line between alchemy and chemistry existed in the 17th and 18th century. Paracelsus mixed magic and valid science in ways that defined modern science. He continued himself an alchemist. However, his idea on poison led to the introduction of chemistry into medicine in the 16th century. Although he was not fully appreciated until his death, medicine would be a different field without his contributions. His ideas were even used to cure Louis HIV. Girolamo Cardano was a pioneer of algebra who was subscribed to alchemy. Bray and his protege, Kepler, believed in alchemy. Bray even had a laboratory dedicated to his studies. Isaac Newton began in the principles of alchemy as he devised his theory of universal gravitation. He devoted more time writing about alchemy than to other optics and physics.
After the Catholic Counter-Reformation, the Church became more hostile.
Isaac Newton, astrology believers were such prominent leaders, such as Queen Elizabeth of England paid astrologers to forecast the future. Girolamo Cardano prepared horoscopes for Edward VI of England. Bray was the court astrologer in Denmark. Kepler was the astrologer to the Australian Habsburg, and Galileo provided horoscopes to the Medici. Astrology experienced a decline during and after the Enlightenment of the 18th century. In the oral culture of peasants, a belief that the cosmos was governed by divine and demonic forces persisted. Everything in the universe, people, the world seemed interconnected. Astrology coextended with religion, magic, and science. The persistent belief in magic was one reason the witch hunts continued well into the 17th century. Terms to know: scientific revolution, Copernicus; heliocentric view, Tycho Brahe; Johannes Kepler; 3 laws of planetary motion, Galileo; laws of motion, telescope, Francis Bacon; empiricism; inductive method, René Descartes; deductive reasoning, cogito ergo sum, I think, therefore I am; Cartesian dualism; scientific method, Isaac Newton; principle of universal gravitation, Principia, 1687; Paracelsus; Vesalius; William Harvey; Anton van Leeuwenhoek; Royal Society; John Harrison; chronometer, alchemy, astrology.